So in here you see page number 86, solution of quadratic equation in complex number set. So it is already known to students that the two roots of a quadratic equation ax square plus bx plus c is equals to 0, where a not equals to 0 and a, b, c belongs to R, are the two root of this quadratic equation are this one and this one. So also in the discussion about the nature of its root, it was stated that when b square minus 4ac is less than 0, then the roots of the quadratic equation are not real. It is because if r is a positive real number and negative r is a negative real number, and then root over negative r, it is equals to I root r, which is an imaginary quantity. Now it is obvious that if b square minus 4ac is less than 0, then root over b square minus 4ac is equals to, I will get root over minus 4ac minus b square is equals to I root over 4ac minus b square is imaginary. So then the above two roots can be expressed as this one and this one. Okay. So these are complex numbers in the form of alpha plus I beta and alpha minus I beta, where alpha is equals to minus b by twice a and beta is equals to root over 4ac minus b square by twice a are reals. Also, one root is the conjugate of the other. Okay, this is important. Also, one root is the conjugate of the other. So far, the students were asked to find solution of equation having real roots only. Now in this chapter, we will discuss the method of solution of quadratic equation having complex roots. Okay. So in here you see, in a quadratic equation, we already learned that in a quadratic equation, there are two roots. There are two roots of a quadratic equation, and those roots I can find out by these two formulas. That means in here the roots, the two roots of a quadratic equation are this one and this one, we can say. Yes. Also in the discussion above, nature of the roots, it was stated that when b square minus 4ac is less than 0, then the roots of the equation are not real. Okay, then the roots of the equation are not real. So when b square minus 4ac becomes less than 0, then the two roots, okay, then the two roots of the quadratic equation becomes this and this one. Understand? And these two are what? They are complex numbers in the form of alpha plus I beta and alpha minus I beta, where alpha is equals to minus b by twice a and beta is equals to root over 4ac minus b square by twice a. Understand? And one root is a conjugate of the other. Understand? One root is conjugate of the other. Understood? Next, it is our example 1. Discuss the nature of the roots of the following equations, also solve them. Okay? Discuss the nature of roots of the following equations, also solve them. So first it is x square plus x plus 1 is equals to 0. So in here you see example 1. Okay, discuss the nature of roots of the following equation, also solve them. So first it is our x square plus x plus 1 is equals to 0 there. Okay, so x square plus x plus 1 is equals to 0. Here a is equals to 1, b is equals to 1 and c is equals to 1. Yes, in this equation a, b, c, all of its value are 1, because ax square, a is what here, 1, plus bx, b is 1, plus c is also 1. Okay, so now in here you see, therefore b square minus 4ac, it will be is equals to 1 square minus 4 into 1, which ultimately gives me 1 minus 4, which is minus 3 and which is less than 0. Okay, so therefore b square minus 4ac is less than 0. So what will be the nature of the roots of the equation? Therefore the roots of the equation, you can say that the roots of the equation are not real. You understand? Roots of the equations are not real. So now you see x equals to it is our minus b. Formula is plus minus root over b square minus 4ac by twice a. Okay, so therefore x equals to b, here it is 1, so minus 1 plus minus root over this one b square minus 4ac, this is equals to minus 3 I got, so minus 3 by 2 I will get. Understand? Minus 3 by 2 I will get. So which is ultimately x equals to, I can write minus 1 plus minus I root 3 by 2 I will get. Understand? So therefore I can say therefore the roots of the equation are minus 1 plus I root 3 by 2 and minus 1 minus I root 3 by 2. Understand? Which I can write it as is equals to minus 1 by 2 plus I root 3 by 2 and minus 1 by 2 minus I root 3 by 2. Okay, if you look nicely, you see these two are complex numbers. Understand? When the roots of the quadratic equation are not real, okay, when the roots of the quadratic equation are not real, then the roots will be what they will be. You see, I am getting these roots as complex numbers. Understand? Where this is you can consider as alpha and this is you can consider it as beta. Okay, and the two roots are, you see, the two roots are, they are conjugate of each other. Yes, the conjugate of this is this and the conjugate of this is this. They are conjugate of each other. Okay, so next number 2, you see this is not a quadratic equation. X to the power 4 minus 1 is equals to 0 there. So first of all I will have to bring it into quadratic equation. So this one, a square minus b square formula, if I apply, I will get these two I will get. So either this is equals to 0 or this is equals to 0. These two I got into two quadratic equation. So the roots of x square plus 1 are I and minus I. Okay, and the roots of x square minus 1, it will be 1 and minus 1. So therefore the roots of the given equation are 1 minus 1 I and minus I. Okay, then next you see sum and product of the two roots. Suppose the roots of the equation ax square plus bx plus c, a not equals to 0 and abc belongs to R, b alpha is equals to this and beta is equals to this. Okay, then the sum of the roots alpha plus beta is equals to this becomes minus b by a. Yes, alpha plus beta, this becomes minus b by a, and the product of the roots alpha into beta, it becomes c by a. So therefore sum of the roots alpha plus beta, it will be minus b by a, and the product of the roots alpha into beta, it will be c by a. Okay, to determine the quadratic equation from the roots, so these things we already know that suppose the roots of the quadratic equation be alpha and beta. Now ax square plus bx plus c is equals to 0. So dividing both sides by a, I will get this. So ultimately it is x square minus sum of the roots into x plus product of the roots is equals to 0. It gives the quadratic equation when roots are known. Okay, it gives the quadratic equation when the roots are known. Now the fundamental theorem of algebra states that every algebraic equation has at least one root, real or imaginary. Understand? Has at least one root, real or imaginary. So as a consequence of this theorem, there is another important theorem which states that a polynomial equation of degree n has n roots. Okay, a polynomial equation of degree n has n roots. Of course, you know that a linear equation, it is linear, means what is degree is 1. So number of roots, how much roots do I get in a linear equation? We get one root. A quadratic equation, this is highest degree, it is 2. So how many roots do I get? We get 2 roots. Understand? So therefore a polynomial equation of degree n has n roots. Okay, therefore a quadratic equation has 2 roots, but when the discriminant of the quadratic equation is negative, then the roots of the equation are complex in nature and one root is a conjugate of the other. This is very important. Discriminant means this is we can consider it discriminant, which is your this one, b square minus 4ac. This is considered, this is the discriminant. Okay, so if discriminant of the quadratic equation is negative, that means b square minus 4ac, it is negative, then the roots are complex in nature. Understand? Two roots we will get and they will be complex numbers, and one root will be a conjugate of the other. Okay, so if one root of the quadratic equation is 2 minus I root 3, then find the equation. So one root is 2 minus I root 3. So the another root will be what? It will be a conjugate of this. It will be 2 plus I root 3. Understand? This is, you see. So the roots are 2 minus I root 3 and 2 plus I root 3. Okay, it will be conjugate of each other. So now we can do sum of the roots. Sum of the roots is this and product of the roots is this. So therefore the quadratic equation is x square minus sum of the roots into x plus product of the roots is equals to 0. So ultimately I will get this. Okay, so now in here you see example 1. Okay, so page number 19, example number 1. Okay, page number 90, example number 1, you see. Find the square root. Find the square root of each of the following complex numbers. Find the square root of each of the following complex numbers. Okay. So now you see, uh, 1 minute. Okay, so first one, it is 5 plus 12i. Okay, I have to find the square root of the following complex numbers. So solution. So we can do it in this way. Square root of 5 plus 12i. This is equals to square root of 5 I can write as 3, 2 into, okay, 5, you see, I can write it as 3 square plus 2i the whole square plus 2 into 3 into 2i. Okay. This one, 5, I can write it as 3 square plus 2i the whole square, and plus 12i, I can write it as 2 into 3 into 2i. So this is ultimately, it gives me root over 3 plus 2i the whole square. Okay, this is gives me plus minus 3 plus 2i. Okay, plus minus 3 plus 2i. So square root of 5 plus 12i, it is equals to this one. Next, it is there your example 2. So that root over I plus root over negative I, this is equals to root 2. So LHS I will take root over I plus root over negative I I there. So this one, okay, this one you see root over, I can write this as in this way, root over twice I by 2 plus, again this is root over minus twice I by 2. Okay, so this is root over twice I can write it as 1 the whole square plus I the whole square plus 2 into 1 into I, okay, by 2 plus this is root over, this is again I the whole square, 1 the whole square plus I the whole square minus 2 into 1 into I by 2. Understand? This 2 I can write it as in this way, because this is 1 square will be 1 plus I square will be minus 1. 1 minus 1 it will cut. Ultimately I'll get 2 twice I only, which is this one. And in here also same. Okay. So now this is equals to, you see, root over, this gives me 1 plus I the whole square by 2 plus root over 1 minus I the whole square by 2. Okay. So this is equals to, it gives me, this one you see, it gives me 1 plus I by root 2 plus, and this one 1 minus I by root 2. Okay. So in here, LCM, if I take root 2, I will get 1 plus I plus 1 minus I. So in here, this one and this one cut. Ultimately, I will get 1 by root 2 I am getting here. 1 by sorry, 1 by, this is 2 by root 2. Okay, 1 plus 1, 2 by root 2 I will get. Okay, so this is equals to 2 root 2 by 2 becomes, okay, both sides if I root 2 multiply 2, then I will get 2 root 2 by 2, 2 cut, which is ultimately is equals to 2. So therefore, this is equals to root 2, which is proved. Understand? So next one you see, next exercise 2.5. Okay, exercise 2.5 we will go. Solve the following equation by the method of factorization. So this is our exercise 2.5, type 1. Solve the following equations by the method of factorization. Number A, x square plus 4 is equals to 0. So this one solution, this one you see I can write it in the form x square minus 2I the whole square is equals to 0. Okay, this one I can write it in the form of x square minus 2I the whole square is equals to 0. Now this is a square minus b square formula. So this one I can write as x plus 2I into x minus 2I is equals to 0. Okay, so either x plus 2I equals to 0 or x minus 2I equals to 0. So therefore x is equals to minus 2I or x is equals to 2I. If we check the back answer, you see x value, it is 2I comma minus 2I. Okay. So next again you see, number B, 9x square plus 16 is equals to 0. So solution, this one we can write as 3x the whole square minus, this one we can write as 4i the whole square is equals to 0. So this one, it becomes 3x plus 4i, 3x minus 4i is equals to 0. So therefore either 3x plus 4i is equals to 0 or 3x minus 4i is equals to 0. So x is equals to minus 4i by 3 or x is equals to 4i by 3. Okay. Next again, number C, 4x square plus 49 is equals to 0. So this one you can write as 2x the whole square, and this one I can write as minus 7i the whole square is equals to 0. So 2x plus 7i into 2x minus 7i is equals to 0. So either 2x plus 7i is equals to 0 or 2x minus 7i is equals to 0. X is equals to minus 7i by 2. X is equals to 7i by 2. Okay. So exercise 2.5 type 2 here. Discuss the nature of the roots of the following equation and solve them. Okay, discuss the nature of roots of the following equation and solve them. So this is already we have done in example. So this one you see 2x square minus 4x plus 3 is equals to 0. So you can write here a is equals to 2, b is equals to minus 4 and c is equals to 3. So therefore b square minus 4ac, which will be is equals to minus 4 the whole square minus 4 into 2 into 3. This is equals to 16 minus 4 2s are 8, 8 3s are 24, which 16 24 minus 16, this gives me 1 2 3 4 5 6 8. So this is negative 8, which is less than 0. So therefore b square minus 4ac, therefore you can write b square minus 4ac, this is less than 0. So therefore you can say the roots in here, how they have given, therefore you can say the roots of the equation are not real. The roots of the equation are not real. Okay, the roots of the equation are not real. So now you can say roots of the equation are not real. After that, you see we can do now the roots are x equals to you write down first minus b plus minus root over b square minus 4ac by twice a, and x is equals to minus x is equals to minus b plus minus root over b square minus 4ac by twice a. Okay, so therefore is equals to minus b value, it is minus 4 there, so minus 4 plus minus 4 the whole square, this is minus 4 into 2 into 3 by 2 into 2 you will get. So this is 4 plus minus root over 16 minus 24 by 4, which is ultimately 4 plus minus root over negative 8 by negative 8 by 4 I will get. Okay, so this is negative 8, that means I can write 4 plus minus I root 8 by 4. Okay, so you see root 8, you can write this as 2 4s are 2 2 2 1. So I'm showing you in here is equals to 4 plus minus I root 8. You can write it as 2 root 2 by 4. From here 2 if you common take, then you will get 2 plus minus I root 2 by 4 you will get. So ultimately you will get 2 plus minus I root 2 by 2. Understand? By 2. So therefore the roots are this one you can write it as 2 by 2 plus I root 2 by 2 and 2 by 2 minus I root 2 by 2. So this one you see, 2 by 2 ultimately you will get 1 here. Okay, you let me check the back answer. 2 number 8. So this is 2 by 2. This one in here only you can write 1 minute. So this is equals to 2 by 2 plus minus I root 2 by 2, which is equals to 1 plus minus I root 2 by 2. Yes, this is equals to I 1 plus minus I root 2 by 2. So therefore ultimately the roots are 1 plus I root 2 by 2 and 1 minus I root 2 by 2. So this is your answer. So rest of the problems you try to do by yourself. Okay, if any problem you can write it in the comment section. Next I will go to type 3. Okay, next I'm going to type 3 here. If the roots of the equation ax square plus 2bx plus c is equals to 0 are imaginary, then prove that the roots of the equation ay square plus 2a plus by plus a plus 2b plus c, this is equals to 0, are also imaginary. Solution. So if the roots of the equation ax square plus 2bx plus c is equals to 0 are imaginary, then prove that the roots of ay square plus 2a plus by plus a plus 2b plus c is equals to 0 are also imaginary. So first of all, the equation is ax square plus 2bx plus c is equals to 0. In here saying that the roots of the equation this are imaginary. Okay, are imaginary. That means it's b square minus 4ac. Okay, so first of all I will consider it as d1. Okay, this is the discriminant. Okay, d1, this is the discriminant. So d1 it is equals to, this is your b here, this whole thing, 2b the whole square minus 4 into a into c. This is equals to 4b square minus 4ac, 4 common, b square minus ac. So d1 is equals to, you can write here where d1 it is equals to discriminant. Let me see the spelling here, discri, discriminant. Okay, so since the roots of, you can write ax square plus 2bx plus c is equals to 0 are imaginary. Since the roots are imaginary, therefore d1 will be less than 0. That is 4b square minus ac. This will be less than 0. Okay, this whole thing it will be less than 0. Understand? And next I will take now this equation. I will take this equation, ay square plus 2a plus by plus a plus 2b plus c is equals to 0. This one I will take d2, okay, discriminant. So in here you see b is this whole thing, 2a plus b, okay. So a plus b the whole square minus 4 into a plus 2b plus c, okay, is equals to, this one I have to show that this whole thing is also less than 0. Okay, so this is 4 a square plus b square plus twice ab minus 4a square. A I will multiply it, 4 minus 4 I will keep it outside only. So this is equals to, I will get 4a square plus twice ab plus ac I will get. Okay, so in here 4a square plus 4b square plus 8ab minus 4a square minus 8 ab minus 4ac. So in here you see this and this cancels out, and this and this cancels out. Ultimately I will get 4b square minus 4ac I will get. Okay, 4b square minus 4ac, and in here this is 4 common, b square minus 4ac, and this one you see I have already said that b square 4b square minus ac, it is less than 0. So therefore let me write, this is equation 1, and so therefore this will be also less than 0 from 1. Okay, this will be also less than 0. Okay, so therefore d2 it is less than 0. Understand? This is d2 I have written in the bracket, you can write similarly like d1 I have written. d2 is equals to discriminant, you can write. Okay, discriminant means that b square minus 4ac. Understand? B square minus 4ac, it is called the discriminant. Okay, it is called the discriminant of the quadratic equation. I have not taken as b square minus 4ac because it is again equals to 2b square, like that becomes. So therefore instead of b square minus 4ac I have written it as d1. Okay, d1 is a discriminant, and this is next, for the next equation I have taken it as d2 which is the discriminant. Understand? So d2 is equals to d2 is also less than 0. So the discriminant of the next equation, discriminant of this is also less than 0. So therefore I can say, therefore roots of the equation ay square plus twice a plus by plus a plus twice b plus c equals to 0 are also imaginary. Okay, are also imaginary. Understand? So next I will go to number 4. Question number 4 here. Question number 4. Find the quadratic equations. Find the quadratic equations with real coefficient, one of whose roots is number A 2 plus 5i. So in here solution. So this one you can write, since the roots of a quadratic equation, equations are conjugate. Okay, this quadratic equation, one root I have already got that this is a complex number. Yes, one root already I got that this is a complex number. Understand? So therefore its roots of the quadratic equation, they will be conjugate of each other. Yes, so therefore since the roots of a quadratic equation are conjugate, 1 minute, let me see in the book how it is done. Discuss the nature of the roots of the quadratic equation sum. Since one of the roots of the quadratic is a complex number, so the other roots you can write it in this way. Since one of the roots of the quadratic equation, since one of the roots of the quadratic equations is a complex number, so the other root is its conjugate. Okay, conjugate complex. So the roots are 2 plus 5i and 2 minus 5i. Understand? So therefore the roots are 2 plus 5i and 2 minus 5i. Okay, now you can say in this way, sum of the roots is equals to 2 plus 5i plus 2 minus 5i, which gives me 4, and product of the roots, this is 2 plus 5i into 2 minus 5i, 4 minus 25i square, 4 plus 25, which is equals to gives me 29. Okay, which is equals to gives me 29. So sum of the roots I got and product of the roots I got. Therefore, the required quadratic equation therefore the required quadratic equation is x square minus sum of the roots into x plus product of the roots is equals to 0. So therefore this will give me x square, sum of the roots 4x plus product of the roots 29 is equals to 0. So this is the quadratic equation. Okay, x square minus 4x plus 29 is equals to 0. Okay, so therefore it is very easy there. Find the quadratic equation with the real coefficient, one of whose roots is this one. Okay, roots is this one. So since one of the roots of the quadratic equation is a complex number, so therefore one root is this one, so other root will be its conjugate. Understand? So the roots are 2 plus 5i and 2 minus 5i. Sum of the roots 4, product of the roots 29. So therefore the required quadratic equation is x square minus sum of the roots into x plus product of the roots is equals to 0. So x square minus 4x plus 29 is equals to 0. This is your answer. Okay. Next you see number B, it is 4i minus 3 there. You consider this as minus 3 plus 4i. So one root is minus 3 plus 4i. So therefore the other root, it will be minus 3 minus 4i. Understand? This one you do by sum and product find out, then quadratic equation you find out. Next it is minus 1 minus I root 3 by 2 there. So this is alpha is equals to, you can take minus 1 by 2 minus 1 by 2 minus I root 3 by 2, and beta you can take minus 1 by 2 plus I root 3 by 2. Understand? And next it is number D, minus C minus ID there. So this is 1 alpha, you can take it as minus C minus ID, and beta you can take it as minus C plus ID. Understand? Conjugate of each other. Okay, sum and product find out and quadratic equation you find out. I hope you have understood. If you have got any doubt, you please write it in the comment section. Next we will go to question number 5. Okay. Question number 5, you see, if x is equals to 3 plus I, then find the value of the expression, x4 minus 4x cube plus 4x square minus 16x plus 60. So this one, how will I do? This is our given. X is equals to 3 plus I. Okay, this is our given. So in here, if I bring 3 this side, so I will get x minus 3 is equals to I. Now squaring both sides, x minus 3 the whole square is equals to I square. This is x square plus 3 square minus 2 into x into 3 is equals to minus 1. X square plus 9 minus 6x minus 1. X square minus 6x plus 9 plus 1 is equals to 0. So x square minus 6x plus 10 is equals to 0. Okay. So now in here what I will do? Now in here what I will do? This one I will divide it by this one. x4 minus 4x cube plus 4x square minus 16x plus 60. Okay, this one I will divide it by x square minus 6x plus 10. Okay, because in here this is our given and I have to find the value of this. So now first of all, x square minus 6x plus 10 into x square I will do. So this is 10x square minus 6x cube and this will be x to the power 4. So x square, x to the power 4 minus 6x cube plus 10x square. So this is minus plus minus. So this one I will get in here 2x cube minus 6x square minus 16x plus 60. Again we will see x square minus 6x plus 10 into 2x, so 20x, and this will be 12x square 2x cube, so plus 2x cube minus 12x square plus 20x, so this is minus plus minus. So this one it will be 6x square minus 36x plus 60. Now x square minus 6x plus 10 into 6, so plus 60 minus 36x, 6x square, so plus 6x square minus 36x plus 60. So I will get 0. Okay. So now in here you see this whole thing, okay, which is this whole thing, I can write it as x to the power 4 minus 4x cube plus 4x square minus 16x plus 60. Okay, this whole thing I can let me write it in here. X to the power 4 minus 4x cube plus 4x square minus 16x plus 60 is equals to, I know that dividend is equals to divisor into quotient plus remainder. Yes, dividend is equal to divisor into quotient plus remainder. So dividend is equals to divisor, this is x square minus 6x plus 10, divisor into quotient. Quotient is x square plus 2x plus 6, and plus remainder it is 0 plus 0. Okay, so now this one you see, this one in here you see, its value it is already I have got that this is equals to 0. This value already I have got. So we will put it in here. 0 into x square plus 2x plus 6, which is equals to 0. This is the answer. Okay. So first of all in here what I will do. First of all in here this is given. I have to, if then find the value of this value I have to find. So x is equal to 3 plus I. 3 I will send it this side. Now squaring both sides I will do. I will expand this in formula, and I square value is minus 1. So ultimately I will get this one. X square minus 6x plus 10 is equal to 0. Now this whole thing I will divide it by this. Okay, I will divide it and answer I will get this one. So now we know that dividend is equal to divisor into quotient plus remainder. Dividend, this is the dividend. This is equal to this into this plus remainder. So therefore this into this plus remainder. This value I have already got, this is 0. Put 0 here. So ultimately I will get the answer 0. Okay. Next you see question number 6. If x is equals to 1 by root 2 1 plus I, then show that x6 plus x4 plus x square plus 1 is equals to 0. So in here x is equals to 1 by root 2 1 plus I, this is given. X square 1 by root 2 1 plus I the whole square, x square 1 by 2 1 plus I the whole square, x square 1 by 2 1 square plus I square, this is I, okay, I square plus 2I x square 1 by 2 1 minus 1 plus 2I. So therefore I will get x square 1 by 2, this one 0 become 2I. So this is ultimately x square is equals to I will get. Okay, x square is equals to I will get. So now I will write this one. I have to show that this is equal to this one. So now LHS equals to, no need to write LHS, you write now x6 plus x4 plus x square plus 1. Okay, x to the power 6 I can write as x to the power 2 to the whole power 3. This one I can write as x square to the whole power 2. This is x square plus 1. X square value it is I given, so this will be I cube this will be I square, this will be I plus 1. I cube value is minus I, this is minus 1 plus I plus 1. So this discard, this discard, ultimately you will get 0. Okay. I cube value is minus I and I square value is minus 1. Okay. So now the rest, next one, number 7. If x is equals to 1 by 2 minus 1 plus and y is equals to 1 by 2 minus 1, then find the value of x square plus xy plus y square. Okay. So now in here you see x is equals to 1 by 2 minus 1 plus root minus 3. So therefore x square, it will be 1 by 2 minus 1 plus root minus 3 the whole square. So x square is equals to 1 by 4 minus 1 the whole square plus root 3 minus root 3 the whole square plus 2 into minus 1 into root minus 3. So next you see x square 1 by 4, this will be 1 plus this will be minus 3 and this will be minus 2 root over minus 3. Okay. So this ultimately gives me x square 1 by 4, this will be minus 2 root 3. So x square is equals to, if I take 2 common here, so 2 by 4 minus 1 minus root over minus 3. So this is ultimately, it gives me x square 1 by 2 minus 1 minus, it gives me this one, x square value. Okay. So 1 by 2 minus root 3, this will be minus root 3 minus 2 1 by 4. Okay. Okay, so in here let me write x square value here. X square is equals to 1 by 2 minus 1 minus, this is the x square value, this is the x square value. Now I will find xy value. So xy, it will be is equals to 1 by 2 minus 1 plus root over minus 3 into 1 by 2 minus 1 minus 3. This is the x square value. Okay, I have written because I rub the solution, so therefore x square value I have written here. Now xy is equals to, this will be 1 by 4 minus 1 plus root over minus 3 minus 1 minus 3. So xy, it will be 1 by 4. This is, you see, a plus b into a minus b form. A plus b into a minus b form. So this you will get minus 1 the whole square, a square minus b square, a square minus b square. So xy is equals to 1 by 4 1 minus minus 3. So xy is equals to 1 by 4, 1 plus 3. So xy is equals to 1 by 4 into 4, which is ultimately 1 I will get. Okay, xy value I will get 1. So let me write xy value here, which is 1. Okay. Next I will go to, you see, y is equals to 1 by 2. I will take out y square next. 3. So y square, it will be 1 by 2 minus 1 minus minus root 3, the whole square. So y square is equals to 1 by 4 minus 1 minus minus root 3 the whole square. So y square is equals to 1 by 4 minus 1 the whole square plus minus root 3 the whole square minus 2 into minus 1 into minus 3. So y square is equals to 1 by 4, 1 plus minus 3 plus 2 root over minus 3. So y square is equals to 1 by 4. This will be minus 2 plus 2 root 3. Okay. So now in here you see, from here if I take 2 common, I will get 2 by 4 minus 1 plus root over minus 3. So this gives me y square is equal to 1 by 2 minus 1 plus root over minus 3. Okay. So y square value I got, y square is equals to 1 by 2 minus 1 plus minus root 3. This is y square value I got. Okay. So now what I will do, I have to find the value of this one. So now x square plus xy plus y square, this will be is equals to, x square value is this one, 1 by 2 minus 1 minus minus root 3 plus 1 plus, and this is the value of y square, 1 by 2 minus 1 plus root over minus 3. Minus 1 plus root over minus 3. Okay, this is equals to 1 by 2 minus 1 minus minus root 3 plus 1 by 2 minus 1 plus root 3 plus 1. This one I am writing in this way so that I can take 1 by 2 common. 1 by 2 common minus 1 minus minus root 3, and this will be again 1 by 2 common coming. So in here minus 1 plus root 3 plus 1. So 1 by 2. In here you see this and this cut. So into minus 1 minus 1, I will get minus 2 plus 1. So this one cut. Ultimately I will get minus 1 plus 1, which is equals to 0. This one our solved. Okay. Next I will go to question number 8. Question number 8. Question number 8. If root over x plus iy is equals to a plus ib, then show that root over x minus iy, this is equals to a minus ib. Okay. So now in here you see, this is our given, x plus iy is equals to a plus ib. I will squaring both side do. Squaring both side, if I do, x plus iy is equals to a plus ib the whole square I will get. Okay. So x plus iy is equals to a square plus ib the whole square plus 2aib. So I will get x plus iy is equals to a square plus I square b square, I square b square, I square minus 1. So a square minus b square plus twice ib I will get. Okay. Now real part and imaginary part I will equate it. Okay. So x is equals to a square minus b square I will get, and y is equals to twice ab I will get. Okay. So now you see x below this is, y below this is. So x minus iy, this will be is equals to a square minus b square minus twice abi. Yes, like that you can write. So now this you see x minus iy, this one I can write it as a square plus ib the whole square. Yes, ib the whole square I will get minus b square. Okay, and this one minus twice aib. Like that I can write. Yes, this whole thing I can write it in this way. Okay, so this is, you see, this is a minus b the whole square formula. This one, a minus b the whole square formula. So therefore I am showing it in here in my space note there. That's right. X minus iy is equals to, I got a minus ib the whole square. So if I take square root both side, I will get iy is equals to square root of a minus ib the whole square. That is, ultimately I will get x minus iy is equals to a minus ib. So this is our solve. Okay, this one I have to show here. This is our solve. Okay, next I will go to question number 9. Question number 9 you see here. Question number 9. Find the value of the following. Find the value of the followings in a plus ib form. Find the value of the following in a plus ib form. Root over negative 3. Okay, in a plus ib form. Root over, first it is root over negative 3. So in here you see a plus ib form I have to show. So root over minus 3, this is equals to, I can write root over minus 1 into 3, root over minus 1 into root over 3. So this is I root 3. So this is 0 plus I root 3. This is in a plus ib form. Okay, this is in a plus ib form. Understand? Next, your number B, root over I. This one you see, root over I can write it as root over twice I by 2. Yes, root over twice I by 2. I can write like that. So this one I can write it as, you see, okay, I can write it as root over twice I into root over 1 by 2. Yes, I can write it in this way. So this one it will become root over, okay, this one you see, this one I can write it as, let me write this in this way. Same thing only, I will write root over 1 by 2 I will write first, then into root over negative, this one I will write. Okay, no problem, like that also you can do. I am writing in here in this way. So root over 1 by 2 into, this one you can write it as 1 minus 1 plus twice I. Okay, this one you can write it in this way. So root over 1 by 2 into root over, this one you see I can write it as 1 square, okay, 1 square plus I square, because I square is minus 1, 1 square plus I square plus 2I, okay, I can write it in this way. So this one it becomes 1 plus I the whole square. Yes, 1 plus I the whole square. Okay, so square and root cancel, so I will get root over 1 by 2 into 1 plus I will get. Okay, so this one multiplied by this one, so this one you see root over 1 by 2, I can write it as 1 by root over 2, 1 plus I. Okay, so this is ultimately I can write it as 1 by root 2 plus I dot 1 by root 2. This is a plus ib form. Okay, this is a plus ib form. So in here, instead of writing this one, instead of writing root 2, instead of writing, in here only you can change it, that this is equals to 1 by root 2 into this. Okay, 1 by root 2, 1 by root 2, 1 by root 2. Okay, so next, question number C, root over minus 9. So this one minus 1 into 9, minus 1 into root 9. So this is I3, 0 plus I3. Next number D, root over minus 3 by 2. So this one you can write as root over minus 1 into 3 by 2. Root over minus 1, 3 by 2. I root over 3 by 2. So this is equals to 0 plus I root over 3 by 2. This is your answer. Okay. Next you see question number 10. Question number 10. Find the square root. Find the square root of each of the following numbers given below. Find the square root of each of the following numbers given below. 8 minus 15i. Okay. So in here you see solution. This one I can write it as 1 by 2 into 2, 8 minus 59. Okay. So find the square root of the following numbers given below. First is 8 minus 59. This one you see I can write it as 1 by 2 into 2, 8 minus 59. Okay. So this one is equals to 1 by 2, 16 minus 30i. So in here you see 1 by 2, 16, this number 16 I can write it as 5 the whole square, okay, plus 3i the whole square, and this one minus 2 into 5 into 3i. Okay, 16 you see I have written as 5 the whole square plus 3i the whole square. You see, 5 square plus 3i the whole square. This gives me 25. This gives me 9i square, which is 25 minus 9, which is equals to 16. Understand? So therefore, 16 minus 3i, I can write it as 5 the whole square plus 3i the whole square minus 2 into 5 into 3i. So now you see 1 by 2. This one, it is 5 minus 3i the whole square formula. Okay. So therefore, square root of 8 minus 15i, it will be equal to square root of 1 by 2, 5 minus 3i the whole square, which is ultimately, it gives me plus minus 1 by root 2 into 5 minus 3i. Okay, this is the answer. Back answer, your answer is there, plus minus 1 by root 2 into 5 minus 3i. This answer is wrong. Okay, this will be the correct answer. So similarly, next one you see, number B, minus 7 plus I6 root 2. Okay, so this one you see, minus 7 there. So minus 7 plus I, this one I can write it as 2 into 3 root 2 I can write. Okay, so 2 into 3i into root 2 I can write. So minus 7 can I do in this way, that 2 the whole square plus 3i the whole square, if I do 4 plus 9i square, 4 minus 9, this is minus 5 I will get. So this is not possible. Okay, you see here, minus 7 how I can bring, root 2 the whole square plus 3i the whole square, if I do, this is 2 plus 9i square, 2 minus 7, 2 minus 9 minus 7 I will get. Okay, so therefore this one you see, minus 7 I can write it as root 2 the whole square plus 3i the whole square. Sorry, this is I will write it in here. Okay, 7 minus 7 plus I6 I have written as 2 into 3i. Okay, I6 2 into 3i into root over 2. Okay, so root 2 the whole square plus 3i the whole square plus 2 into 3i into root 2. Okay, understand? So therefore this is root 2 plus 3i the whole square formula. So therefore square root of minus 7 plus I6 root 2, this is equals to square root of root 2 plus 3i the whole square, which is equals to plus minus root 2 plus 3i. This is the answer. Plus minus root 2 plus 3i. This is the answer. Okay. So next again you see number C, m square minus twice minus 1. So this one in here you see, this one I can write as, okay, let me write it, m square minus twice im minus 1, m the whole square, and this will be minus 2 into m into I, okay, plus I square. Okay, because I square is minus 1. So therefore this is m minus I the whole square. So therefore square root of m square minus twice I m minus 1, it is equals to square root of m minus I the whole square, which gives me plus minus m minus I. This is my answer. Okay. Next again it is number D you try to do by yourself. Okay. Number D try to do by yourself. If any problem there, then you can tell me. Number D you try to do by yourself. I'm going to number E, x plus I root over 1 minus x square. So in here you see x plus I 1 minus x square. So this one you can write it as 1 by 2 into 2 x plus I 1 minus x square. So 1 by 2 2x plus 2I 1 minus x square. Okay. So therefore 1 by 2 2x plus 2I. This one you see I can write it as 1 minus x into 1 plus x. Okay. So this will be is equals to 1 by 2 2x plus 2I root over 1 minus x into root over 1 plus x. So now in here you see this is 2x there. Let me see one thing. If I do in this way, 1 minus x the whole square plus 1 plus x the whole square. Okay, if I do in this way, I will get 1 minus x plus 1 plus x, which gives me 2. Okay, this one it gives me 2. So in here I there, if I do this in this way, okay, if I do this one in this way, root over 1 minus x the whole square plus I root over 1 plus x the whole square, if I do, I will get 1 minus x plus I square 1 plus x. So this gives me 1 minus x minus 1 plus x. 1 minus x minus 1 minus x. So this gives me minus 2x. Okay, it does not give me 2x, it gives me minus 2x. So let me do one thing here. If I do this, root over 1 plus x the whole square plus I root over 1 minus x the whole square. Let me see what I get. 1 plus x plus I square 1 minus x. 1 plus x minus 1, 1 minus x. 1 plus x minus 1 plus x. So this gives me 2x. This one I got. Yes, this gives me 2x. So therefore this whole thing I will write in this way. Let me show it in here. This whole thing I will write in this way. 1 by 2. Okay. 1 by 2. In place of 2x I will write root over 1 plus x the whole square plus I 1 minus x the whole square. Okay, in place of 2x I will write this, because I have already solved and showed you that these things gives me this one. So after that I will write this one. Yes, plus 2i root over 1 minus x and root over 1 plus x. Understand? Okay. So now 1 by 2, this is, you see, a plus b the whole square formula, this one. Okay, a plus b the whole square formula. So 1 plus x plus I 1 minus x the whole square. Okay, so therefore square root of x plus I root over 1 minus x square, this is equals to square root of 1 by 2 root over 1 plus x plus I root 1 minus x the whole square. So this is ultimately gives me plus minus 1 by root 2 1 plus x plus I 1 minus x. This is the answer. Okay, square root of this one, it gives me this. So next again you see number f. Okay, number f, it is minus 2 root minus 3. So solution. So minus 3 there. In this one I can write it as root over minus 3 the whole square minus 1. This gives me minus 3 minus 1 plus 1, I can do plus 1, and minus 2, this will be square, and minus 2 into plus 2i square. How can I express this one? Can I write it as I root 3 the whole square plus I root 3 the whole square minus 1 square minus 2 into 1 into I root minus 3. This is plus I square. Can I write it in this way? Minus 3 the whole square minus I square. This is, it will give me minus 3 plus 1 minus 2 I will get. Okay, minus 2 I will get, and this is minus this will be minus 2 into root over minus 3 into I we can do. But in here I, it is not there. That is also a problem. Minus 2 there. If I take 2 common, minus 1 minus root 3. So this one okay, this one you see minus 2 root minus 3 there. So this is, I can write it as minus 2 I root 3. Okay, because root over minus 3, I can write it as I root 3. Okay, so now our root 3 the whole square minus I square minus 2 into I into root over minus 3. Now let's see whether this thing gives me minus 2 or not. This is 3 plus 1 gives me 4. If I do plus 1, if I do plus 1 here, this thing gives me 3 minus 1. It gives me no. I cannot do in this way. I root 3 the whole square plus 1 minus 2 into I root 3. This will be I square into 3 plus 1. Minus 3 plus 1 gives me minus 2. Okay, this one I can do. Okay, first of all I got this one. So now I can do here is that minus 2 I can write it as I root 3. Okay, minus 2 I can write it as I root 3 the whole square the whole square plus 1 square. Okay, plus 1 square wait a minute, I root 3 the whole square minus 1 square I square 3 plus 1 yes plus 1 square minus 2 I root 3. Okay, into 1 you can write, no problem. So this one it gives me I root 3 minus 1 the whole square. So therefore square root of minus 2 root minus 3, this is square root of I root 3 minus 1 the whole square. Okay, so this is ultimately gives me plus minus I root 3 minus 1. This is the answer. Let's check the back answer. 1 minus this is back answer. It is 1 minus root 3 I there. I root 3 the whole square plus 1 square. I square 3 plus 1 minus 3 plus 1 minus 2 only I will get. Okay, so in here you see this is also your correct there. 1 minus, so no problem. This is also correct there. Back answer 1 minus I root 3 there. If you want to match it with the back answer, you can do one thing. If you want to match your answer with the back answer here, you can do one thing. Either in here you see, either in place of writing like that, either you can write 1 square. Okay, you see 1 square plus I root 3 the whole square minus 2I root 3 into 1. So this gives me 1 minus I root 3 the whole square. Okay, so therefore this square root, if I take square root of 1 minus I root 3 the whole square, this is ultimately I will get plus minus 1 minus I root 3. Okay, and or in place of this, in here you can take minus 1 common. If you take minus common, then in here you will get 1 minus I root 3 the whole square. Okay, now square there, so this is minus there. Ultimately what you will get? Ultimately you will get this one only, you will get 1 minus I root 3 the whole square. Ultimately this only become. Okay, so my previous answer also correct there, and if you want to match it with the back answer here, you can write 1 square plus I root 3 the whole square minus this one you can write. Okay, so next it is number G. Number G you try to do by yourself. Okay, if you are not able to do, you please write it in the comment section. So next, type 11. Type 11 it is simplified there. Type 11 it is simplified there. Root over 5 plus 12y plus root over 5 minus 12y by root over 5 plus 12y minus root over 5 minus 12y. Okay, so in here you see solution. This is root over 5 plus 12y plus root over 5 minus 12y by root over 5 plus 12y minus root over 5 minus 12y. Both side I will rationalization do, plus root over 5 minus 12y root over 5 plus 12y plus root over 5 minus 12y. Okay, so this is now is equals to, this becomes root over 5 plus 12y plus root over 5 minus 12y the whole square by root over 5 plus 12y the whole square minus root over 5 minus 12y the whole square. So this is equals to, I will break it into formula, 5 plus 12y the whole square by 5 minus 12y the whole square plus 2 root over 5 plus 12y into 5 minus 12y by 5 plus 12y minus 5 minus 12y. Okay, so now again in here is equals to, this becomes 5 plus 12y plus 5 minus 12y plus 2, this one root over 5 square minus 12y the whole square by 5 plus 12y minus 5 plus 12y. This one gone. So now in here you see this one in here, this and this gone. So 10 plus 2 root over 25 minus 144i square by this, it will be 24i. So is equals to this one, 10 plus 2 root over 25 plus 144 by 24i. So next it becomes 10 plus 2 root over 169 by 24i. Okay, so this one, let me do it in here, is equals to 10 plus 2 into 13 by 24i. So this it gives me 2 into 13 26, 26 plus 10 36 by 24i. So this is 36i by 24i square. This is ultimately, it gives me 36i by minus 24. Okay, 36i by minus 24 it gives me. So in here okay, this is it gives me. So this one you see, if I cut it, is equals to 36i by 24 minus 24. This one 2 12s are 2 ones are 2, 2 8 is 16, 2 6, 2 9, 3 2, 3 3. So this one, if you cut and bring it to lowest term, you will get minus 3i by 2. This is your answer. Understand? This is your answer. So next, the last one, question number 12. The last one, you see question number 12 here. Question number 12. So that root over minus 2 plus 2i root 3 plus root over minus 2i root 3 is equals to 2 there. So solution. So that this is equals to this, I have to solve. Okay. So in here, first of all, I will take the left hand side, root over minus 2 plus 2i root 3 plus minus 2i root 3. Okay, this is equals to, you see, root over, this is minus 2 there. So you see, this minus 2, I can write it as 1 square plus I root 3 the whole square. This minus 2, I can write it as 1 square plus I root 3 the whole square. Okay, because y in here, you see, I square plus I root 3 the whole square, this is equals to 1 plus I square into 3. 1 minus 3 I will get, so ultimately minus 2 I will get. So minus 2 I can write as 1 plus I root 3 the whole square. Okay, and this one it will be 2 into I into root 3. Okay, this one we will write it in this way, 2 into 1 into I root 3. Okay, then again this one, minus 2 minus this one, again this one, you see, minus 2 again, 1 square plus I root 3 the whole square, and this is minus 2 into 1 into I root 3. So in here, this one, you see, it is a plus b the whole square formula, a plus b the whole square formula, and this one a minus b the whole square formula. So this is equals to, I will get 1 plus I root 3 plus 1 minus I root 3. So in here, this and this cut ultimately is equals to, I will get 2, which is equals to RHS. Okay, which is equals to RHS. Understand?